Hey folks, in this video I want to talk about what it means for something to be like a good hash function. So overall there's going to be three different things we're looking for, and they're kind of up there in bullet points, right? Consistent, efficient, uniformly distributed. So we're looking for these three different properties. So let's walk through these a little bit. Okay, so the first one, consistent. Consistent is basically saying if I hash the same thing twice, I better get the same value back. Because if I don't have that property, what happens is, it's like, well, I have an object, I do a hash on it, I get, this one number one time, and I get, next time hash, I get another number another time. Well, I'm never going to be able to use that to look something up, right? That number is all of a sudden more looking like a random number rather than a number that tells me something useful, right? So it's no longer an ID if it changes. All right. Middle thing there is efficient to compute. So efficient to compute is kind of maybe an odd thing to write. Now, what we've seen before, right, if you look back at basically the code we had in the previous video that did the hash code implementation in Java, that basically looked like an O of n or O of 1 implementation of a hash code. So you're like, oh, that's fine. And that's what we're going to see in this class. But if you were to look at kind of more advanced techniques for doing hashing, what happens is you get to a lot of stuff that basically is very expensive. It's like, well, I can get a very good hash, right? It's consistent, uniformly distributed, but all of a sudden the hash function is like O of n squared or O of n cubed or something else that maybe is really bad. We don't want that, right? Ideally, right, we want to basically make sure that our hash function looks like O of 1. Because if our hash function isn't O of 1, well, then we're not going to be able to create a data structure that has constant time lookups, right? We know using the array is constant time, but then in order to use the hash function to compute the index in the array where stuff is stored, that hash function should be O of 1 as well, right? If it's more than that, then it's going to slow down the whole thing. Okay, so last thing here is uniformly distributed, and we talked about this a little bit. So just as a refresh, right, the idea is I have some sort of an interval, right? It's like, well, these are all the possible hashes I could generate, from negative max int to basically to max int. And what I basically want to say is that whenever I create an object from a class and I put some stuff in it, the hash code that it gets assigned is uniformly distributed, right? So it's like sometimes over here, sometimes over here, sometimes here. They don't cluster up in one particular position. They're spread out over the entire range. That's what I want. The reason why I want that is because I don't have as many collisions if they're all spread out. Now, the problem here, and this is a big problem, is we can't really do it, right? We can't have a perfect uniform distribution. That would actually be impossible for us to do. So we're not gonna, we're not gonna do it, right? We're going to claim that we are, and we're gonna do it basically as a way to give us some way to do performance analysis, right? So later on at some point we're gonna have this talk about, how fast is this data structure, and we're gonna spend the time to do a little bit of math and figure out what it looks like, how many comparisons or how many exchanges are needed. But when we do that, we're basically going to assume that our hash function is what we call a perfect hash. And so a perfect hash is one where everything inside of it is being evenly distributed over the range. Now for us, right, we'll build hash functions, right, and we'll hope and dream, right, that they are indeed uniformly distributed, but most likely they won't be, right? Most likely they'll only use part of the domain. They won't be mathematically perfect. Now it's okay, but it's just something to keep in mind, right? We'll strive for it. We'll use it during analysis, but we probably won't get it, right? The one thing that can get there, right, is something that is a perfect hash, and a perfect hash is a little bit beyond the scope of this class. Actually, so way back when I was a student, they actually had an entire, at ASU in Tempe, they had an entire graduate level class, 500 level math class that was perfect hashing functions, okay? So in order to create a perfect hash, the equivalent knowledge is at least one complete semester of graduate level math coursework. And so we don't really have that much time, so we're not gonna be talking through it. For now, again, we'll just kind of do our best, right? Try to strive to get there, and then use it during our analysis. But we won't talk about how to specifically build a perfect hash.